Bismillahirrahmanirrahim. Uh, Dear girls, I hope you are doing well. Today, my topic is electronic configuration of first 18 elements, which is the topic of chemistry class 9th. Let me define electronic configuration first. It is the distribution or arrangement of electrons around the nucleus in orbits or shells of an atom, right? Girls, Bohr stated that electrons in an atom do not revolve randomly, but they revolve in certain fixed circular paths, which are called the orbits or shells. Uh, the orbits or shells, uh, I have drawn it here in this diagram. You can see this is the nucleus. First shell is K, second is L, M, N, O, P, and so on, right? I have written here number one is first shell, which is the name of which is K. The name of second shell is L. The name of third shell is M, fourth, N, and so on, right? So, uh, the filling of the electrons, the distribution of electrons in these shells or orbits is done according to a formula. But before that, I would like to tell you that each shell has subshells. The total number of subshells is 4, that is S, P, D, and F, right? Uh, as you can see it over here, S, P, D, and F. S subshell, each shell has subshells S, P, D, and F, right? Let me tell you, first shell is K, it has only one subshell, that is S. Second is L shell, it has two subshells S and P. M, which is third shell, has S, P, D, and S, P, and D, three subshells. N, which is the fourth shell, it has S, P, D, and F, four subshells, and so on. The remaining higher shells will have four subshells each, that is S, P, D, and F. Now, let me tell you, the number of electrons in each subshell is also fixed. Each subshell has a maximum capacity of a fixed number of electrons, like S subshell of each shell can hold maximum number of 2 electrons, right? P subshell of each shell can hold maximum number of 6 electrons. D subshell of each shell can hold maximum number of 10 electrons, while F subshell of each shell can hold maximum number of 14 electrons. So, S subshell can hold maximum number of 2 electrons. Less than 2 is possible, but not more than 2. Similarly, in the P subshell, less than 6 is possible, but not more than 6. And same is the case with other subshells, right? So, the filling of the electrons is done on the basis of a formula that is 2n square, where n is the number of shells, right? Uh, when we take the example of first four shells, which is, as you know, K, L, M, and N. I told you K has maximum 2 electrons, has 8, M has 18, N has 32, and so on. How this maximum number of electrons was decided? It was decided on the basis of this formula, which is 2n square. N is the number of shell. You know, first shell is K, which is number one shell. We will fill the electrons on the basis of this formula. N is the number of shells. So, when we put this formula, instead of N, we will put the number of first shell, which K, which is 1. We will take square of 1, which is 1, multiply it with 2, then it is equal to 2, right? Then L shell. L is the second shell. We will put the value of 2. 2. Instead of n, take the square of 2, which is equal to 4, multiply it with 2, and then it comes out to be 8. Similarly, come here to third shell, which is M. Here uh, third shell, the square of 3 is taken, which is 3 multiplied by 3 is equal to 9, multiplied with 2 by 2 is equal to 18, right? Then n, which is fourth shell, the square of 4 is taken, which is equal to 16, and 2 multiplied by 16 is equal to 32. Then hence we say that first shell K has maximum number of 2 electrons, L has 8, which is here, M 18, N is equal to 32, right? Let's do the filling of electrons in the first 18 shells, elements of the periodic table. You can see it here in the on page number 67 of the book. You can see first element is hydrogen, second is helium, third is lithium having atomic number 3, beryllium atomic number 4, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon having atomic number 18. We are doing the electronic configuration from atom hydrogen up to atom argon, right? So, let's do the filling of electrons in these atoms or elements. I have drawn a pattern of filling these electrons, which is drawn on page number 51 of the book, class 9th chemistry. But I have redrawn it here to make it more clear. Element, symbol, atomic number, and electronic configuration. So hydrogen is the first element, helium second, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, and we will do the rest of the elements too. Hydrogen has symbol H, atomic number 1, means it has one electron. So I will fill this electron into the first shell K, which is first shell K, and I told you it has only one subshell, which is S. But I have given this subshell number 1 because it is the subshell of first shell, right? K is the first shell, so I have written it 1s. Then I have to put one electron into this shell, subshell of the K shell. Then I will write it in like 1s1. 1 is the number of electron. This 1 is showing the number of shell. S is the subshell, and this one is showing the number of electron. So the electronic configuration of hydrogen will be 1s1, right? Then we come to second element, helium. Symbol is He. Atomic number is 2, means it has 2 electrons. So these 2 electrons have to be filled first into the lowest energy level or shell, which is K, which is closest to the nucleus. K, as you know, it has only one subshell S. So these 2 electrons will be put over here. One is showing the number of shell K. S is the subshell, and 2 is showing the number of electrons. So the electronic configuration of helium will be 1s2, right? Then lithium. Lithium has symbol Li. It has atomic number 3, means it has 3 electrons. So I will put these 3 electrons into the shells and their subshells respectively. Now I will take a start from first shell. 3 electrons will be filled in the first shell, which is K, and which is given number 1, right? And it has only one subshell S. So I will not write 1s3 because S subshell has maximum capacity of accommodating 2 electrons. So I will put only 2 electrons over here, 1s2. Then the remaining third electron will be shifted to the second shell L, and it will be shifted to the lower subshell of the L shell, which is S. So I will write 1s2, 2 electrons in the first shell, right? Then the remaining third will be shifted into the S subshell of this L shell, and it will be written as 2s1. So electronic configuration of lithium will be 1s2, 2s1, right? Then we come to beryllium. Beryllium has 4 electrons, atomic number 4. Its electronic 4 electrons will be filled into the first into the K shell and then into the L shell. K shell has only one subshell S, L has two subshells S and P. So 4 electrons will be uh, filled in this way, 1s2, and the remaining 2 will be over here 2s2. The electronic configuration of beryllium will be 1s2, 2s2. Then we come to boron having symbol B and atomic number 5, means 5 electrons, which will be put into these subshells of these shells like this, 1s2. The remaining 3 will be over here, 2s2, total 4. The fifth will be shifted to the P subshell because S shell has maximum capacity of only 2 electrons. So it will be shifted to the P of the second shell. The electronic configuration of boron will be 1s2, 2s2, 2p1, right? Then we come to carbon, symbol C. Atomic number 6 means 6 electrons. Then these will be put in this order, 1s2, 2s2 and 2p2.